Hello friends, I am Dr. Sudhan Sharma from School of Computers and Information Sciences, Indira Gandhi National Open University. And today's session is in continuation of our earlier session, which was three-dimensional geometry and introduction. In our earlier session, we discussed about various concepts like direction ratios, direction cosines, and we also understood the distance between the 2 points. Now, in this session, we are going to explore some more details about the equations of the straight lines. We are going to learn about the vector form of the equation, parametric equation, Cartesian equation. Apart from this, we are also going to learn how to determine the shortest distance between the two lines. So, the objectives of the today's sessions are to find the equation of a straight line passing through a given point and parallel to a given vector in a vector form and the Cartesian form. Apart from this, we are also going to learn how to find the vector and Cartesian equations of a line passing through two given points. Further, we are going to discuss about what are skew lines and coplanar lines. And finally, we are going to conclude the session by finding the distance between the two skew lines. So let's begin with the first and the important concern is to understand about the equations of the straight line. We all know that there is a famous equation of straight line y is equal to mx plus c. Now m is the slope, and we learned that slope is nothing but in when we learned about the differentiation is dy by dx. So that means change in the value of y, that is y2 minus y1 upon x2 minus x1. So if there is a line whose starting point is say x1 y1 and ending point is say x2 y2, then the angle subtended by the line with x-axis is theta, and tan of theta represents the slope of the line, that is m. And we can always find the slope of the line by using the formula y2 minus y1 upon x2 minus x1. So that means if I use this, say this is equation number 1 and this is equation number 2, using 2 in 1, we can always say that y is equal to y2 minus y1 upon x2 minus x1 multiplied by x plus intercept c. That means in order to draw, say we are into two-dimensional system x, y, and say there are 2 points, this is x1, y1 and x2, y2. Then in order to have each and every point on the line, what is line? Line is locus of infinitely close collinear points. So in order to have each and every point onto the line segment, we need to compute the difference of the two coordinates y2 and y1, x2 and x1, multiply it with the value of x and add some intercept into it. That means two subtraction operation, one multiplication operation and one division operation is just to perform and just to calculate one of the ordinate value y. So that means this is an expensive task. So it was required to explore the alternative forms of these straight lines, and there are different forms of the straight lines. Likewise, we are going to discuss in this session, we are going to discuss about the parametric form of the equation of straight line, and the Cartesian equivalent of the equations of the straight line. So let's understand what is the parametric equation of the straight line. So if we say that there are again 2 points, say point P and point Q, and coordinates of point P are say x1, y1, and coordinates of point Q are x2, y2. Then the parametric equation of line is given by point line segment P plus T, Q minus P, where T is the parameter whose value varies from 0 to 1. Now, looking at these two expressions, we can say that when value of T is equal to 0, then this equation will gives us only point P, that is the starting point P. And when value of T is equal to 1, then same equation will give us the point Q. That means if the value of T varies from 0 to 1, then we are going to have the series of points in between point P and point Q, and that was required for the generation of the line. But over here, if we compare the equation y is equal to mx plus c, which was equivalently written as y2 minus y1 upon x2 minus x1, y2 minus y1 upon x2 minus x1, that is the slope of the line, into x plus c. Here the complexity is quite high because two subtraction operations are to be performed, one multiplication is to perform, one division is to be performed, one addition is to be performed. So total number of operations are 1, 2, 3, 4, 5. So 5 operations are to be performed. But in this case, only one addition, one multiplication, one subtraction, 3 operations are to be performed to get the series of points from point P to point Q. So the complexity of this line is quite low in comparison to the equation of this line. So that means the mathematicians has explored different equations of the line, and these lines are having different benefits, and so we are going to learn about the different equations of the lines in this session. So the first and the foremost, we are going to begin with the equation of the straight line passing through point A and parallel to a vector B. So referring to this figure, this vector B is parallel to AP. Say there is point O and vector A is pointing to point A on the line, and now vector A is directing in this direction, and TB, that is vector B, is parallel to this line segment. So this is TB vector, then the resulting vector will be given by R. So applying the triangle law of addition of vector, vector A plus TB will be equal to vector R. That means you can always say this is the equation of the line. This is, you can rather say that it is the vector equation of line. We simply applied the triangle law of addition of vector by saying that OP is equal to OA plus AP. OP is equal to OA plus AP. That is A plus AP, and AP is nothing but T times of vector B. And this representation of the line is the vector equation of line because it involves all the three components which are vectors. R, A and B, all three are vectors, and T is the scalar quantity which is a parameter. So T is a parameter, and that means if we are supposed to find the equation of line passing through point A and parallel to vector B, then the equation of the line is given by R is equal to A vector plus T times of B vector. Because this is a simple formula you need to remember, and T is the parameter. So, that means R is equal to A plus TB is the vector form of the equation line, vector equation of the line. Now, if we want to find the equation in the form of the Cartesian form, so say the vector, say point A has got the coordinates x1, y1, z1, then applying simply the understanding of the vectors, we can always say that A vector is equal to x1 I unit vector plus y1 j unit vector plus k z1 k unit vector, which is this. And say the direction ratios for are A, B, C, then B vector can always be expressed as AI plus BJ plus CK, where A, B, C are the direction ratios. Therefore, vector B is given by A plus AI plus BJ plus CK. As a result of which, substituting these values, that is equation number 1 and equation number 2, into the vector equation, say we call it equation number 3, then we can get the vector form R equal to, say we represent R by the general expression xi plus yj plus zk. Substituting these values in equation number 3, you can always get xi plus yj plus zk is equal to A plus TB. So, A vector is x1 I plus y1 j plus z1 k unit vector plus t times of b unit vector, that is ai plus bj plus ck. So that means by rearranging these equations, you can say that you can always write it x1 plus tai plus y1 plus tbj plus z1 plus tck. On the left hand side, you are having the r vector, that is xi plus yj plus zk. Comparing the coefficients of I, j and k, you can say that x is equal to x1 plus ta, y is equal to y1 plus tb, and z is equal to z1 plus tc. And this implies t is equal to x minus x1 by a, which is also equal to, by equation, say we say this is 1, this is 2, this is 3. Then you can always rewrite them as y minus y1 upon b and z minus z1 upon c, z minus z1 upon c. So these three equations are there, and these three equations are expressed as, you can call these three equations as the parametric equations, whereas the equation which we derived by rearranging these parametric equations, these three are the parametric equation, that is x is equal to x1 plus ta, y is equal to y1 plus tb, and z is equal to z1 plus tc are the parametric equation because they involve the parameter t. But if we rearrange these equations, we can always say that t is equal to x minus x1 upon a, and also y minus y1 upon b, also z minus z1 upon c. So all of these expressions are equivalent to t. So this expression is the Cartesian equation of the straight line. So we learned that there are three types of equation. First is your vector equation, which says that r is equal to a plus tb. Second is parametric, this is our vector equation line. So in the parametric form, you can say always x is equal to x1 plus ta, or y is equal to y1 plus tb, z is equal to z1 plus tc. Rearranging these parametric equation lines for the parameter t, you can get this equation rearranged into x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c, and this is nothing but the Cartesian equation of the straight line, and where a, b, c are the direction ratios. In our earlier sessions, we also learned about the relation between the direction ratios and direction cosines, and on the same lines we can always say that x minus x1 upon L is equal to y minus y1 upon m is equal to z minus z1 upon n, where L, m, n are the direction cosines, and this is also the Cartesian equation of the straight line passing through point x1, y1, z1 and having the direction cosines L, m, n. Whereas this is the Cartesian equation of the straight line passing through point x1, y1, z1 and having direction ratios a, b, c. So we learned the formulas and they are consolidated over here. We learned this equation, r is equal to a plus tb. We learned the parametric equation, x is equal to x1 plus ta, y is equal to y1 plus tb, z is equal to z1 plus tc. We learned the Cartesian equation of straight line passing through point x1, y1, z1 and having direction ratios a, b, c can be expressed as x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. And if the direction cosines are L, M, N, then the equation can be rewritten as x minus x1 upon L is equal to y minus y1 upon m is equal to z minus z1 upon n. So all these 1, 2, 3 and 4, these equations are different forms of the equations of a line passing through a point and parallel to a given direction. Now the next important concept is to understand what is the equation of the straight line passing through two given points, not one point. Now we are going to refer about the 2 points. So let a and b be the 2 points having the coordinates say x1, y1, z1 and x2, y2, z2 and having the respective position vectors say A and B as shown in this figure. Say this vector A is pointing to the point A on the line, and this vector B is pointing to the point B on the line L. So this is line L, and these two are the vectors which are pointing to the lines. Now again applying the same, this is line L, this is some point O, and this is some point A onto the line. So this is the vector and this is point B on the line having the coordinate x2, y2, z2. So by applying the triangle law of addition of vectors, OA plus AB is equal to OB. So that means you can always write that AB is equal to OA minus OB. That means AB is equal to, you can always write that B vector minus A vector. So AB is equal to OB minus OA. OB minus OA, not OA minus OB. It should be OB minus OA, that is equal to B vector minus A vector, which is written over here. So that means the direction ratios are in the form B minus A. So we can always write the equation, vector equation, the line passing through point A and parallel to AB vector as R is equal to A plus T B minus A. And in earlier case, when there was a single point, we wrote it R is equal to A plus T B. So this equation R is equal to A plus T B minus A is the vector equation, the line passing through 2 points with the position vectors A and B. We can always rearrange this equation R is equal to A plus T B minus A into the form R is equal to 1 minus T of A plus T times of B vector. Just by opening the braces and rearranging the terms, we can get this equation. So both equations are one and the same. We just rearrange the equations. So just to remember, when the equation of line was regarding for 1 point, then R is equal to A plus TB. When it is talking about 2 points, then you need to apply the expression R is equal to A plus TB minus A. Now, as in the earlier session part, we determined the Cartesian equation of line when we were referring only the single point. Now, we are going to derive the Cartesian form of the equation from the vector equation. So, we learned that A and B are the position vectors. So, of the point A and B, where the coordinates of A are x1, y1, z1, and coordinates of point B are x2, y2, z2. Therefore, the position vector A will be expressed by x1i plus y1j plus z1k, and position vector of B will be represented by x2i plus y2j plus z2k. And the resulting expression in the Cartesian form is xi plus yj plus zk. Again, substituting these values into the expression R vector is equal to A vector plus T of B vector minus A vector, that is our this equation, we can get xi plus yj plus zk is equal to x1i plus y1j plus z1k plus T times of x2 minus x1i, y2 minus y1j, z2 minus z1k. Now, equating or comparing the ith, jth and kth component on the left hand side and right hand side of this equation, you will get x is equal to x1 plus t x2 minus x1, y is equal to y1 plus t y2 minus y1, z is equal to z1 plus t z2 minus z1. Now, rearranging these equations, let me arrange one equation for you, x1 plus t x2 minus x1 will be rearranged to t is equal to x minus x1 upon x2 minus x1. And similarly, the other expression will be y minus y1 upon y2 minus y1, and z minus z1 is equal to z2 minus z1. and this is the final equation, which is the Cartesian form of the equation of the straight line passing through 2 points x1 y1 z1 and x2 y2 z2. So, this is the Cartesian form of the equation, this is the vector form of the equation of the line passing through 2 points. Now, let us solve some numericals. In this numerical, we are supposed to find the equation of the line both vector and Cartesian form passing through the point this and parallel to the vector this. So, one point is there and other vector is parallel. So, that means the equation is to be applied is A plus TB. Now, A vector given to us, this is the point. So, the vector form will be 1i minus 1j minus 2k. So, this is vector A, and second vector to which it is parallel, that is t times of B. So, B vector is nothing but 3i minus 2j plus 5k. So, one point equation is to be applied, and one point equation of line is A plus TB. So, R is equal to A plus TB. So, A component we substitute A and B in this equation, and we got this as an expression. Rearranging the equation, but this is the vector form. Now, after rearranging, we will get the Cartesian form. So, when we are going to rearrange this equation, that is separating the I component, j component and k component, you got 1 plus 3ti minus 1 plus 2tj minus 2 plus 5t k. And on the left hand side, you are having xi plus yj plus zk. So, that means equating left hand side and right hand side for the coefficients of I and j and k, you will get x is equal to 1 plus 3t, y is equal to minus 1 minus 2t, z is equal to minus 2 plus 5t. That means you can rearrange these expressions and you will get t for first equation is x minus 1 by 3, for second equation it is y plus 1 by minus 2, and for third equation it will be z plus 2 by 5. So, this is the Cartesian equivalent of the equation of straight line passing through point 1 minus 1 minus 2 and parallel to the vector 3i minus 2j plus 5k. I hope you understand how we applied the understanding of equations in the vector form and the Cartesian form to solve the numerical. Now, let me solve one more numerical for you. Find the vector and Cartesian equation of the line passing through 2 points. Now, 2 points are there. Point A is given to you as minus 2, 0 and 3, and point B is given to you as 3, 5 and minus 2. So, that means say this is represented by vector A, this is represented by vector V. So, the vector form of the equation of line will be R vector will be equal to A plus T times of B vector minus A vector. So, that means we need to calculate B minus A. So, we know that A vector, which is this is the I component, this is the j component, this is the k component of vector A. So, A vector is equal to minus 2i plus 0j plus 3k. Similarly, we are having B vector is equal to 3i plus 5j plus minus 2k, which are given over here. Now, subtracting A from B, you will get B minus A as 5i plus 5j minus 5k. Substituting these values, that is in this equation A plus T B minus A, and solving, you will get the expression for the vector form of the equation of straight line, and that will turn out to be minus 2 plus 5ti plus 5tj plus 3 minus 5tk. So, that means minus 2 plus 5 minus 2 plus 3k is there plus this. So, rearranging minus 2 plus 5t I 5tj 3 minus 5tk. Equating the left hand side and right hand side, you will get x is equal to minus 2 plus 5t, y is equal to 5t, and z is equal to 3 minus 5t. Now rearranging this equation for the parameter t, you will get t is equal to x plus 2 by 5, t is equal to y by 5, and for the third equation you get t is equal to z minus 3 by minus 5. So all are equal to t. So x plus 2 by 5 is equal to y by 5 is equal to z minus 3 by minus 5 is the Cartesian equation of the straight line passing through 2 points which are given to us, and this is the vector equation of the straight line passing through 2 points given to us. Now many a times the question might be framed into a situation like the Cartesian equation is given to us and you are supposed to find the vector equation of the line. Recalling that in the Cartesian equation, the denominator part refers to direction ratios, or if it is specified then it is direction cosines also, and the numerical part, the integer part or real numbers given in the numerator are the referring to the point through which the line passes. So referring to this equation and comparing this equation with the equation given to us, you can find that x1 is equal to minus 3 because we are giving x minus x1 upon a. So x1 is equal to minus 3, y1 is equal to 2, and z1 is equal to minus of 5. Similarly, you are having a is equal to 4, b is equal to 5, and z is equal to 1. And you all know that in the vector equation line, for one point it is you can say x1 I plus y1 j plus z1 k plus t times of ai plus bj plus ck. So substituting x1 y1 z1 and abc, you will get this equation, and this equation is nothing but the vector equation of the line. So from the Cartesian equation, you determine the vector form of the equation of the line. Now there is an important concept about the angle between the two lines. Say there is one vector, say r, and there is another vector, say r dash, and there is some angle theta in between the two, and r dash are given by, say r is given by the equation a plus tb, and r dash is given by, say, a dash plus t b dash. Then the angle between the two is given by this expression, that is cos theta is equal to magnitude of b b dash. This is the dot product of the two vectors upon the magnitude of b vector and the magnitude of b dash vector. So the entire magnitude will give you the angle between the two lines which are given over here. So let's apply this concept and find the angle between the two lines r and r dash. So you got by referring to the equation r is equal to a plus tb, and r dash is equal to a dash plus tb dash, you get that b vector given to us is nothing but this is the b vector and this is the b dash vector. So we need to, by referring to this formula, that is modulus of b dot b dash upon divided by modulus of b into modulus of b dash, that is the magnitude part. So we need to calculate b dot b dash, that is dot product of the two. So dot product, you all know that I dot I is equal to j dot j is equal to k dot k is equal to 1, and all other things I dot j or j dot k all turns out to be 0, because in this case the theta is equal to 90 degree and a dot b is nothing but magnitude of a into magnitude of b into cos theta, and cos of 90 degree is 0. Cos 90 degree is 0. So that means we need to multiply I component with the ith component, j component with the jth component, k component with the kth component. So 1 into 3 is 3, minus 2 into minus 2 is 4, 2 into 6 is 12. So in the numerator you will get the answer 19, that is 3 plus 4 plus 12 is 19, and in the denominator the magnitude of vector b and magnitude of vector b dash are to be found. And the magnitude, you all know that if the vector is having say xi yj plus zk is the vector, then the if b vector is say xi plus yj plus zk is the vector, then magnitude of vector b will be given by square root of x square plus y square plus z square. So the given vector b over here is 1 minus 2j plus 2k. So magnitude of b should be square root of 1 square plus minus 2 square plus 2 square, that is square root of 9, that is equal to 3. Magnitude of b dash vector should be equal to square root of 3 square plus minus 2 square plus 6 square. So that means 9 plus 4 13 plus 36 is 49. So square root of 49, that turns out to be 7. So you are having 3 and 7. So 7 3 the 21. So 19 over 21 is the value for cosine of theta. And you can always determine theta by taking inverse of 19 by 21. So this is the angle in between the two lines. Now we need to find if the lines, equation of the lines are given in the Cartesian form, that is x minus x1 upon a1 is equal to y minus y1 upon b1 is equal to z minus z1 upon c1, where x1 y1 z1 are the point coordinates of the point through which the line is passing, and a b c a1 b1 c1 are the direction ratios. And say this is the equation of the first line and this is the equation of the second line, then the angle between the two lines will be given by a1 a2 plus b1 b2 plus c1 c2 upon square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. So a2 square plus b2 square plus c2 square. So this is the equation a1 a2 plus b1 b2 plus c1 c2 upon square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. Now if instead of direction ratios we take the direction cosines, that is L M N, that L1 M1 N1 and L2 M2 N2 as the direction cosines of the two lines, then the angle between the two lines will be simply given by L1 L2 plus M1 M2 plus N1 N2. And the two lines will be perpendicular if this expression, that is L1 L2 plus M1 M2 plus N1 N2 is turns out to be 0. Then that means cos theta is equal to 0, and then theta is equal cos theta 0 when theta is equal to 90 degree. Similarly, they are parallel, that means the lines with the direction cosines L1 L1 M1 N1 and L2 M2 N2 will be parallel if L1 by L2, the ratio of the direction cosines is equal, that is L1 by L2 is equal to M1 by N2 is equal to N1 by N2. In this condition the lines are parallel. Apart from this, if we want to only refer to the direction cosines, then direction ratios, that means say instead of L1 M1 N1 we are having the direction ratios A1 B1 C1 and A2 B2 C2 for the two lines, then the lines are perpendicular if A1 A2 plus B1 B2 plus C1 C2 turns out to be 0, and they are parallel if the ratio of the direction ratios, that is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So these are some of the observations when the equations of line are known to you into the Cartesian form, then how to determine the angle in between the two lines. Now let's solve some numerical, where in this case we are supposed to find the angle between the pair of lines x minus 5 by 2 is equal to y minus 3 by 1 is equal to z minus 1 by minus 3, and we are again given a second equation line x minus 3 is equal to y minus 1 by 2 is equal to z plus 5 by minus 1. So we need to find the direction ratios. So for the first line, that is this line, the direction ratios are 2, 1 and -3. So direction ratios for the second line are 3, 2 and -1. So 3, 2 and -1 are the direction ratios for the second line. So we knew the direction ratios of the first line, that is A1, B1, C1, and we also determined A2, B2 and C2. And we all know that if the direction ratios are known, then the angle between the two lines is given by A1, A2 plus B1, B2 plus C1, C2 divided by square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. So that means substituting the values and solving, you will get this expression, and after solving this expression you will get the answer 11 upon 14. So theta will be cos inverse of 11 by 14. I hope you understand that we use this expression, this formula, to determine the angle in between the two lines whose direction ratios are given to us. Now, the next important point is to find the shortest distance between the two lines. But in order to understand this concept, firstly we need to understand what are coplanar lines, when the lines are non-coplanar, and because the understanding of these 2 points relates to find the situation that when the lines are skewed. So skew lines are the two non-coplanar lines which are neither parallel or nor intersecting. So coplanar lines, that is those lines which exist on the same plane, and non-coplanar lines which does not exist onto the same plane. Now over here some lines are shown over here in this figure. You can see that line green and yellow, this yellow color line and green color line are on the different planes. Similarly, violet color line and blue color line are on those simple, all are onto the separate planes. So they are non-coplanar lines. Now what are skew lines? Two or more lines are said to be skewed, that means, or if they are non-coplanar and they are neither parallel nor intersecting. So you can see that all these lines which are shown in this figure are non-coplanar lines, neither they are parallel to each other nor they are intersecting. So there are few conditions, few properties for identifying the skew lines, that they continue in different directions forever. So you can see that all lines are moving in different directions. They are in different planes. Yes, all are in different planes. They are never parallel. Yes, they are never parallel, and they never intersect. You can see that they are never intersecting to each other. So such lines are skewed lines. Now the shortest distance between the skewed line is supposed to be perpendicular to both lines, and now we are going to understand what is the shorter distance. So say if this is the line and these two are the parallel lines, then the shortest distance is going to be the perpendicular distance in between the two. Now if two lines are moving, there might be different situation. If the two lines are parallel, then the distance between the lines, this might be the distance, this is the distance, this is the distance, this is the distance. So all distance are all are the distances in between the two lines, but the shortest distance will be the minimum distance, and the minimum distance is going to be the perpendicular part. So we are going to explore this concept in more mathematical manner. So let's two lines are given to us. Say line 1 is A plus T B A1 plus T B1, and line 2, that is R2, is A2 plus S B2, where T and S are the parameters, respective parameters. We learned that if a line with single point and is given to you, then the equation of line is equal to R A plus T B, where A and B are the position vectors and T is the parameter. We already learned about this in the beginning of the session, where A1 and A2, you can refer to this figure that A1 and A2 are the points on line L1 and L2 respectively. B1 and B2 are the direction vectors for the lines of B1 and B2 are referring to the direction vectors. and for the lines L1 and L2, and T and S are the parameters. T and S are the parameters for the line 1 and line 2. Then the distance form, the shortest distance formula, the formula for the shortest distance will be given by D is equal to magnitude of A2 minus A1 dot B1 cross B2 divided by magnitude of B1 cross B2. So, you can interpret that this is nothing but the scalar triple product. We explored the concept of A dot B cross C, and we learned that this is equivalent to ABC, and we learned in our earlier session that ABC is equal to BCA is equal to CAB when we were exploring the different properties of the scalar triple product. So, now this understanding is used over here to find the shortest distance. So, we learned that if A1 and A2 are the 2 points onto the line L1 and L2, and B1 and B2 are the direction vectors for the line L1 and L2 with parameters T and S, the line are represented by, say, R1 is equal to A plus TB1, and R2 is equal to A1 plus TB1, and R2 is equal to A2 plus SB2. Then the shortest distance between the two lines will be given by A2 magnitude of A2 minus A1 dot B1 cross B2 divided by magnitude of B1 cross B2. So, now if the equations are given to us into the Cartesian form, so that distance, that means this formula is applicable when we know the equations of the lines in the vector form. If the equations of the lines are known to us into the Cartesian form, let it be x minus x1 upon L1 is equal to y minus y1 upon m1 is equal to z minus z1 upon n1, where L1, m1, n1 are the direction cosines, then you can use the formula. This is again same formula, A2 minus A1 dot B1 cross B2. So, this is A2 minus A1. You can see that similarly A2 minus A1. So, it is x2 minus x1, y2 minus y1, z2 minus z1. Now, dot product is there, B1 cross B2. So, x component, if we remove the x component, we are referring to the x component. Now, what are remaining components? M1, N2 and M2, N1. And you are seeing that M1, N2 minus M2, N1. So, we are using the concepts of, say, how we solve the determinant. We learned na, if A cross B is to be found, then it is I, J, K, A1, B1, C1, A2, A1, A2, A3. You can always say, you can say it A1, A2, A3, B1, B2, B3. We applied this formula and you got that this is the first expression M1, N2 minus M2, N1. Similarly, if we are going for the y component, then y2 minus y1. So, we are referring to y2 minus y1, and we are taking the difference of these 4 quantities, that is n1 L2, n1 L2 minus n2 L1. Similarly, z component is to be evaluated. So, z2 minus z1 is to be taken care of. So, third component is z2 minus z1, and this is again L1 M2 minus L2 M1. So, this is the third part, and it is very simple, and now in the denominator it will be again M1 and 2, same thing. These things will be, this expression is replicated over here, this expression is replicated over here, this expression is replicated over here. So, we are taking the square of these things. So, the formula is quite simple to remember, and it is very similar to A2 minus A1, A2 minus A1 into B1 cross B2 divided by magnitude of B1 cross B2. So, this was the distance, and it is, this formula was applicable when we were referring to the vector form, and this formula is applicable when we are referring to the Cartesian form of the equation of line. So, the formula is quite simple, and you learned about the analogy, how to remember this formula, and it is not difficult. And now we are going to apply this formula to solve the numericals in our subsequent slides. But before that, the expression this was the expression when we were having the equation in the vector form. So now C minus A or B cross D, this is one and the same thing. R is equal to, if say A plus TD and R is equal to C plus TD, then you can always say that A2 minus A1 is represented by C minus A, and B1 cross B2 is represented by B cross D, and magnitude of B cross D. And we this formula is nothing but this formula. So the numerator is only replaced by x2 minus x1 into y2 minus y1 into z2 minus z1, a1 b1 c1, a2 b2 c2, divided by these values, wherein b1 c2 minus b2 c1 square plus c1 a2 minus c2 a1 square, and again a1 b2 minus b2 a2 b1 minus a2 b1 square. So they are all are same. This is for the vector representation. Let me rewrite. Say if we are having, say, r1 is equal to a plus tb and r2 is equal to c plus td. This is the vector form, and we in our earlier we represented the expression is a plus tb, a1 plus tb1 and a2 plus tb2. Both are same. So earlier we use this. If the expression is written this, then in the vector form this is the formula, and in the Cartesian form this is the formula. This formula and this formula both are same. So this is just to let you understand that the formula can be expressed into the determinant form also, for your better understanding. And if you can understand the analogy, then you can simply apply this formula also. So in the self-learning material, this formula is given in your self-learning material, and I had included this formula just for your better understanding, just for your just to understand it in the simpler manner. So if you are going to refer to the self-learning material, you will find that the formula which is followed is for the vector form is C minus A into A cross B divided by magnitude of B cross D. So you need not to worry about, or both concepts are one and the same thing, and let's apply these concepts to solve the numericals. So this is the numerical over here. Now the Cartesian form of the equation of the line is given to you, is x minus 5 by 4 is equal to y minus 7 by 4 is equal to z plus 3 by minus 5. And second equation of it 2 is given to is x minus 8 by 7, y minus 4 by 1 is equal to z minus 5 by 3. So that means you are given two vectors in the, if we represent these equations into the vector form. So representing this equation into the vector form. So this you will get this one, and representing this Cartesian equation in the vector form, you will get equation this one. We learned these points are x1, y1 and z1. So what is x1? x1 is 5, y1 is 7 and z1 is minus 3. So that's why this is 5y plus 7j minus 3k. And in the denominator you are having 4, 4 and minus 5. So that's why t times of the other equation is 4i plus 4j plus minus 5k. So this is nothing but, you can say that a plus t b. So a plus tb. So what is a? A is this. What is b? This is b is this. So again, referring to the next equation given to us, transforming this Cartesian form given to us into the equivalent vector form. Let's see how. This is x2, this is y2, this is z2. So, this x2 is 8, y2 is 4 and z2 is 5. So, that is why the equation is 8i plus 4j plus 5k. Now, in denominator 7, 1 and 3 are given to you. So, s times of 7i plus 1j plus 1j plus 3k, and this equation is nothing but c plus sd, c plus sd, and this was a plus tb. So, we got a as, what is a? A is this. What is b? B is this. So, a is this, b is this, c is this, this equation is c, d is this. So, this equation is this. Now, the formula in the vector form is c minus d dot b cross d. So, c minus d is subtracting c minus a. So, is equal to c minus a will be this value. So, subtracting component of a from c. So, that means you will get, so referring to these equation. So, c minus a. So, 8 minus 5 is 3. 8i minus 5 is 3i. 4j minus 7j is minus 3j. 5k minus 3k is 8k. So, you got c minus a as, what is this? 3i minus 3j plus 8k. And you calculated b cross d. So, what is b? B is given to us as 4i. This expression is b, this expression is d. So, b cross d will be 4, 4 and minus 5. So, 4, 4 and minus 5, and d is 7, 1 and 3, 7, 1 and 3. Now, solving the determinant, you will get this is expression, that means c minus a into b cross d. So, c minus a turns out to be this, and b cross d turns out to be this. This is b cross d. Now, taking the dot products, that is I multiplied by I, j multiplied by j, k multiplied by k, you got the answer 51 plus 141 minus 192, and 51 plus 141 is 192. So, 192 minus 192 is equal to 0, and if the shortest distance, that is this distance, is equal to 0, then obviously this means that the two lines intersect. So, it is to be noted that if you are supposed to determine that whether the two lines intersect or not, then you need to find the shortest distance, and if the shortest distance turns out to be 0, then it obviously proves that the lines intersects with each other. So, I hope you understood what are the different forms of the line, how to perform the calculations. We learned about the coplanar lines, skewed lines, we learned about the vector equations, parametric equations, Cartesian equations, and when the line is passing through one point having direction ratios, when the line is passing through 2 points, and we also determined the angle in between the two lines, and by this the third unit of the block number 4, that is the 3-dimensional geometry, is completed. And I request you to go through the self-learning material, try attempt as many questions as possible for the better understanding. Thank you.